So we had solved it up till this point. So we had found out the reduced level of the second change point, and now we had to proceed further. So when we again changed the location of the instrument, we took the first reading at the point of known reduced level, which is the benchmark, which is station number 8, and the reduced level is 101.535. So now what we have to do is we have to find out new height of the instrument, which we will use in further calculations. So since we have the reduced level, so that means there is this point on which we took one reading from the previous setting, and that was the foresight in the previous setting. And using the previous height of the instrument and previous foresight, this point became our benchmark. We found out the reduced level of the point, which is 101.535. Then we changed the setting of the instrument, and now we need to find out the new height of the instrument. So on the same point, we took a new backside, which is 1.225. So now what we have to do is that in the reduced level of this point, 101.535, we will add the backside 1.225, and we get the new height of the instrument, which is 102.760. So now that we have that, we can proceed to the next point. So the height of the instrument would remain the same. The intersight is 2.390. So from 102.760, we will subtract 2.390 and we get reduced level of the next point. So then we have the last reading. So the last reading would become the foresight for this setting of the instrument. From the same height of the instrument, we subtract the foresight and we get the last reduced level. So reduced level of the last point. So now that we have done this whole procedure, now we have a reduced level of all the points. Now we can apply the check that we studied in the previous lecture. So the check was that at the end of these computations, the summation of all the backsides minus the summation of all the foresights should be equal to the difference between the last reduced level and the first reduced level. So in our case, the summation of backside is 7.5 and the summation of foresight is 5.860. We leave out the intersights and the difference is plus 1.64. Our last reduced level is 99.725 and the first reduced level was 98.085. So their difference is also plus 1.640. So since the two match, that means the computations are correct. So this is how you do it with the height of instrument method. Now we will do the same question by the rise and fall method. Now the difference in two methods is only in this part. So before this, setting out the table is the same. So you just set out the table once, and in the first case, instead of rise and fall, you write height of the instrument. But in the rise and fall method, instead of that, you add in one more column and you write down rise or fall. So, like we discussed, the rise and fall method, in this method, you only keep into perspective the two readings that you are taking. So, in our case, on the first point of known reduced level, we took the backside, and the next reading that we took was the interside. So their difference is actually the rise or fall between the 2 points. And it's always the reduced level, or not the reduced level, the staff reading of the first point minus the staff reading of the second point. So that would always be backside minus foresight or backside minus interside in this case. So backside was 3.15 minus the first interside 2.245. That gives us a positive answer, so that means it is a rise. Had it been a negative answer, that would have been a fall. So this basically means that the second point is at a greater elevation than the first point. So now that we have calculated the rise, you will just add it in the reduced level of the first point, and the second point was 0.905 meters above the first point. So by adding, you get the reduced level of second point, which is 98.990. Now you move to the third point. Now we are talking about the difference in elevation between second point and third point. In height of instrument, in the same setting, we took a lot of points and we compared all of them with the height of the instrument. But in this case, once you're done with the first point, you forget it. Then it's second and third. Then it's third and fourth. Then fourth and fifth. So you keep forgetting the previous points. So now we would compare the intersight of the second point with the intersight of the third point. So 2.245 minus 1.125. Again, we have a rise of 1.12, and you add it in the reduced level of the previous point, which is 98.990, and you get reduced level of the third point, which is 100.110. Then we move to the fourth point. Now the two readings that you have to compare are the intersight of the previous point, which is 1.125, and the foresight of the next point, which is 0.860. And since this was with the same setting of the instrument, you cannot compare it with the backside because that reading is with a new setting of the instrument where the height of the instrument and the location has changed. So the rise and fall method for a set of readings only works if all the readings are taken with the same setting of the instrument. So now for the next point, since by subtracting 0.860, which is the foresight, from the previous reading, which is the intersight, we get again a rise. We will add this rise in the reduced level 100.110, so that we get the reduced level of the change point, which is 100.375. Now this is when you change the location of the instrument. So now that I've changed the location, I've moved to the next location of my instrument. The reading I take on the previous point is my backside, 3.125, and the reading that I take on the next point, whose reduced level is unknown, is now the intersight. So backside 3.125 minus the intersight 2.760. Again, we have a rise of 0.365. You add it in the previous reduced level, you know the drill, and you have now the reduced level of the next point. Similarly, you move ahead, and the intersight of the first point minus the intersight of the second point, again we have a rise. Then intersight of the first point minus the intersight of second point, again we have a rise. And then from intersight, you will subtract the foresight. Now the second reading is bigger than the first reading. So now you would get a negative answer, and now you have a fall. So from the previous point, 102.03, you subtract the fall value 0.495, and we get the new reduced level of the change point, which is 101.535. And this is how you can proceed and do the calculations for the remaining points as well. So as you can see, the rise and fall method is pretty simple. All you have to do is remember, from the first reading you have to subtract the second reading. If it's a positive answer, it's a rise. If it's a negative answer, that's a fall. And the first reading can be a backside or an intersight, and the second reading can be an intersight or it can be a foresight, depending on when you change the location of the instrument. So this is how you perform the computations. So if you fill up the table correctly, then it becomes very simple. So this was the first numerical. The second one and the last one in the set of slides, you should try that by your own. So it's the only difference from this question is that in that question, instead of the reduced level of the first point, they have given you reduced level of the last point, and you have to do the calculations backwards.